Good morning, my name is Gary and welcome to my home workshop. I was very surprised by how well my first video was accepted by the community. I had expected maybe 6-7 people would like it, and in the first couple of weeks I've had 5,000 views, I've got 350 subscribers to my channel. It's just a little bit overwhelming, particularly when I look and see that many of my YouTube heroes have subscribed to the channel and actually sent me some very complimentary comments on that. So based on that, I started working on a second video, and that was using my metal shapers. And I started that video and I ran into some technical difficulties, actually some rather embarrassing technical difficulties. I was filming a cut, it went beautifully, it would have made great footage, but guess what? The camera ran out of memory just as the cut was starting. And it was a sizable cut on my 20-inch shaper. Made some nice chips. And anybody says that shaper chips don't clang, well, I give you a little evidence to the contrary. So what I'm going to do today is I'm going to do something a little bit different, something I hadn't planned on doing quite so quickly, but several people had asked me questions about how I ground the shear tool. And there's nothing unusual about that. I'm just basically following what I read in books. But I'm going to go through that process and take the tool bit that I've used and basically sharpen up the edge so I can do it again. And then I'll talk a little bit about the quality of the finish that I can get using this type of grind, because I had some other people ask me questions about that. So what today's going to be basically a grind. So let's get to it. We're now in the somewhat cluttered corner of my small shop. There's never enough room, and if you can imagine that my shop started off in what I will call a half-car garage. It might have been big enough to park a Harley in it, but a car, yeah, you could put one in, you just couldn't get in and out. And trying to cram some machines in there. My second shop, while I was living in Illinois, was a 2/3 of a 3-car garage, and at least there I could move around with some safety. When I moved to my present location, I had a detached garage that I was able to turn into a shop, and of course shops fill up with machines and you run into space problems. So back here is my grinding corner. I used to grind all of my tool bits offhand, and this is a Chinese BR Tools bench grinder. Okay, and actually I've been very happy with this one. I have had this since the 1990s. It has always run smoothly for me. I've never had any problems with it. I know Keith Fenner bought a grinder recently, did a video on it, and he had a tremendous amount of repair work to do to it straight out of the box. I was a little bit luckier when I got this. I don't know if it's because it's older, because it's a different brand, whatever. I bought this just at a tool sale down at the local fire hall, and it's worked fairly well for me. Now I know that Adam Booth has done some videos on grinding lathe bits recently, and he emphasized the importance of having the table centered with the center of the wheel, and you notice that mine is not centered with the center of the wheel. It was originally. I added these tables later, but the reason is I'm just an amateur. I don't have all the skill, or maybe I just don't have the patience that some of the professionals do, or I haven't done it as many times. But trying to judge the angles by eye, to save myself a little trouble, I made this little block with a milling machine. And what I can do with it is I can hold a tool bit in it at the right angle, and when it sits on here, it then holds it at the proper location. So that's the way that I was doing a lot of my small lathe tool bits in the past, and it was a nice little, very simple project. I've got different angles on here, and it allows me just to make sure that every time I hold the tool up against the wheel, I'm getting it at the same angle as I did before. And it worked fairly well for me. Today though, on my shear bit, I'm looking at it, this edge still fairly good. This one is a little burned in the corner, so I want to take that down. So the first thing I'm going to do is just do some rough grinding and basically remove some metal. What I've want to do is keep the edge at about a 25-degree angle, okay, to the long axis. This is a 3/4 by 1 by 6 Momax tool blank. I've already grounded at 25 degrees there before, so I don't need to measure that. I can see that. So the first thing I'm going to do is just remove a little bit of metal, get some rough clearance on this thing so that I can work on it a little bit later. So to do that, I'm going to put some eyes on. I tend to put ears on as well. Not that this is going to be all that loud. And let's get to grinding. Now I have it roughly where I want it. And for anybody that's interested, the yellow cans of diesel fuel do not contain diesel fuel. They contain a water-based soluble cutting oil, about 98% water, so I am not grinding next to flammable liquids. This is my Gorton 375 tool and cutter grinder. It is designed primarily for sharpening end mills, and it comes with a very nice workhead on it that has a number of different degrees of motion on it, different scales on it. You rotate things around, advance things in and out, change the up and down angle, a variety of different things to control the relief that you want to have, the rake angles and so forth on your milling cutters. There's some stops built into it and so forth, and very fine precision drive. But it uses 4NS collets. These are fairly small collets. I made a couple with square holes in them so that I could grind small lathe tools, but looking at what we're trying to do right here, there's no way that there's going to be any collet that I'm going to be able to make to hold this tool bit. So I wanted to use this for grinding lathe tools, not so much to get the precision on the angle, but to just be able to get a nice smooth surface against the wheel and hold it at the same angle all the time. And to do that, I realized I needed to remove this and come up with a different holder. I'm going to turn this around and I'm going to remove the commercial workhead, and I'm going to show you the holder that I developed. Now I puzzled about this for a long period of time. How could I mount something on here that would hold a tool bit the way I wanted to hold it? And I wanted something that could rotate. I wanted something underneath to hold it so that I could see what was going on. And the problem was there just simply wasn't enough clearance underneath. And I puzzled about this for a while, but eventually I had a momentary cessation of stupidity and I came up with the right idea. This is the holder that I came up with. And the trick behind this is, instead of trying to hold it underneath, I can hold it on top. This has a slot in the end where I can put the tool. I have various holes that I can adjust to get the tool angle correct. And then I've got a couple cap screws that will hold the tool in place. So in the present situation, I can feed the tool bit in, tighten it in place, and the cap screws allow the tool bit to defy the laws of gravity and not fall out. I have a small slot here. Center of this slot is 30 degrees off. What I'm wanting to do on this tool bit just swim it out a little more. Get it about there. And in fact, I'm going to just set my mark on 0. Tighten the nut. And I want this to be at 90 degrees. So get under on the scale. Set the angle properly. And as I said, this is at 30 degrees, but there's a slot here. I know this slot is about 10 degrees long, so I can go each side of it. My target is 25 degrees, so I go halfway over. Tighten it up. Let's see how that fits. I think what I want to do, because much of what we do on this for lathe tools is just eyeball it. Right about there ought to be perfect. You may have noticed the machine was rocking, and that's because I moved things around over here. I just put a wedge under it to keep it from moving. So you may have noticed the machine was rocking a moment ago. I put a wedge underneath it to stop that. That's because I just moved the machine to this location and I hadn't set it up yet. Let's put some eyes and ears on and get ready to grind. What I'm going to do, touch off, all I'm trying to do is just square the face up a little bit. Never taking more than a couple pounds of in on the rough side. Let's take that down to about 1,000. Of an inch and a bit. Very light passes. I think that should be good enough for that side. Now, I need to remove the tool holder. And turn it so I can do the other side. For those who haven't figured it out, one end is for left-hand cuts, one is for right-hand cuts. Tool bit, keep fingers underneath because I honestly believe that gravity works. Lock it back into place. And check the alignment. I think I've done very well on the first guess. This is a Cincinnati No. 2 tool and cutter grinder. It's probably about as standard a cutter grinder as a Bridgeport is a milling machine. So it's a very nice tool. It's got a lot of versatility to it. When I bought this machine, I was lucky enough that it came with the surface grinding attachment. Now, I don't know why they call it a surface grinding attachment, but basically it was a vise that was on a 90-degree head so it could rotate in 2 dimensions. I had another 90-degree onto it, so that I now have 3 different axes of rotation, and that gives me the flexibility I need to do the cut. Now, some people will leave the shaper tool just ground smooth like I had over on the Gorton grinder, but what I want to do is put a hook in the end. And this gives a real sharp edge to it, because that allows it to do a very good job on the shearing cut, better than just having like a 90-degree edge there. So get the rake angle down quite a bit less. So I've got the tool set up. I've got 90 degrees set on this index, so this is just vertical. Over here, I've set it to 65 degrees, which is 90 minus 25. And actually, I've adjusted that just a little bit more because of the way the tool is fitting in here. So I'm going to set my tool in and line it up with the edge of the wheel. Put that in place. Now, one of the things that I want to make sure of is that the workhead height is even with that of the tool, and I can sight in there and see that. Okay, so I've got the workhead in. This is set at 90 degrees, with just about a half a degree off. It's not going to have anything to do with the cut that I'm doing right now, but I would need that if I were doing, say, a 6-inch slab mill on here between centers, so that I only get cutting on one of the 2 sides. This particular wheel is dressed on the outer corner so that it has a slight radius there. And so what that's going to allow me to do is put a hook in here right at the end where I want it to be. And this is a 5-inch diameter wheel. So with the angle that is on here, the radius of this hook is going to be on the workpiece. It's going to be a little bit less than 5 inches on there. So this is a 3-phase machine, so I have to start the phase converter in order to do the cut. So on this cut, I'm going to be moving the table in and out. Okay, it's very fine feed. I'm not going to be moving it back and forth, or if I do, it's going to be a minimal amount. I got the differential driving gauge. I got the stop pins to keep the table from moving back and forth, because it'll move if I push. These are spring-loaded stop pins, so I can move the table against them, but it's not going to be moving of its own accord. But that should do it. Nice chip groove in there. This will be cutting. Could go a little deeper, but it's going to be in the area. It's not worth it. Not where the cut's going to be. So we need to turn it around for the other way. And this should be fairly simple. So I've moved the vise around, rotated this 180 degrees, set the tilt, line things up. I turned the spindle a few degrees because I need clearance back here between the wheel and basically this part of the 90 degree. Otherwise, I'd end up grinding my machine away, and I don't want to do that. It's not going to have a whole lot of effect out here. There's a very small wheel arc in here. We're grinding a groove, of which only a small part is actually part of the cut, so the ends of it aren't going to matter. And I line things up on center, got my tool bit in, sticking out maybe a little more than I want, but we're doing very light grinding cuts, so I don't think that that's going to be a problem. Gone through, check all of my other bolts, make sure everything is tight. Moving the one back here, and the one underneath. I've got the dog set. Again, with the spring pressure, I can still move it either way if I want to, but it's going to just naturally sit there in the middle, seems about the right place, and I'm ready to grind. Back to the Gorton grinder, and I have it set up now. What I'm going to do is I'm going to grind a curve on the end, and that's the most important part of the shear tool. I want the radius of that as long as I can make it. I've got the machine backed out. I wish I could get a little bit more, but to do that I'd have to get a thinner grinding wheel on here, and I'm not going to change out the wheel. So this is going to have a little bit more curve than what I'd like to see for a tool bit this size. But what it's going to do is it's going to give me a nice smooth finish. Now I have the tool bit turned up so that I have the right rake angle for back rake on there. That's about 10 degrees. And then I've got it set so that as I pivot, okay, the tool bit surface is flat, and perhaps a little more adjustment on that. And that way I'll keep a constant back rake going across the bit. So turn in there, and then I'm going to just be turning in and just pivoting right around as I go. So let's cut. Now let's talk about the finish that I can get using a shear tool. And I've described it before as something that I can't really feel the roughness with a fingertip, maybe just a little bit, but it's evident with a fingernail. Let's think about theoretically what we can do on this. I talked about how I ground the edge at a 25-degree angle to that. And I've got a curved radius on there, somewhere around 2.5 inches on this particular one. So if I take 25 degrees, 90 degrees minus 25 degrees, 65 degrees on that. So instead of the tool going straight into the work where I'd be having a radius of that 2.5 inches along there, it's actually turned 25 degrees, which is basically making it sharper. It's as if it has a smaller radius on there. 65 degrees, cosine of 65 degrees is somewhere around 0.4, maybe a little more than that. So let's say the radius is 2.5 inches, maybe a little less than that. So I've got an effective radius of about 1 inch. Now, on the planer, the crossfeed stroke is, as I said before, about 12.5 thousandths. And just doing some square root approximations in my head, some simplifying formulas, 12 thousandths square that, or 12.5 thousandths, so 12 times 13 is 156. Divide that by 2, I ought to be getting about 78 microinches of finish. If I go to the large genie shaper where the fine feed going across is 10,000 of an inch, 10 squared 100 divided by 2 should be get about 50 micro-inch finish. And if I go to my small Atlas shaper, where I can get 5/1000ths of an inch, 5 times 5, 25 divided by 2, somewhere around 12.5 micro-inch finish. That's the best I can do, and that's coming because the curved circle is basically making a little wave through there. So each cut gives me a portion of a circle, and it's just simple geometry working through that. I did some approximations doing this in my head, so if you want to get pencil and paper out, do it right, probably come close to those numbers. A few years ago I started out with a piece of junk steel that was rusted like this, had welds all over it, and I just cleaned it up using my Atlas shaper. And what I was trying to do was to see how good a finish I could get on it. This is what I was able to do with the Atlas shaper after playing around a little bit. As you can see, I've got a very smooth finish on it. There are a few dings in it. That's because I later used this as a pad underneath the machine. I used it on a press. I banged on it a few times. That's what the dings are. But the underlying finish, as you can see, is almost reflective. It's a very smooth finish, and it's not the type of thing you would expect to be able to get out of a piece of junk steel, and in particular trying to get that finish to continue across several welds that are on the top, the bottom, and the one side. So I would say that the Atlas shaper with a shear bit did very well cleaning this up and making a very smooth finish. So it was a bit of a grind today, but I managed to get my tool bit sharpened the way that I'd like to have it. There's more than one way to do any job, and this is just the way that I did this one this time. I'm sure that the pros have a number of ways that would speed this up. Certainly in a production environment, I'm sure people figured out how to do this very, very quickly. But as I said, I'm just an amateur working at home. The one question that I do have for the pros, though, is how do you keep your hands so clean? I look at your videos, and I can't do it. Y'all have a safe day.